So I am Akul Jamwal and I work as a junior engineer at RF Systems Private Limited. And I am here to talk about UML model today. Now, RF Systems started in 2011 and we specialize in software development of test and measurement softwares. We are present in US as well as India, but we are globally recognized all around the world by our partners as well as customers. Before I start, I would like to give a big shout out to all the women in aerospace and defense sector that have made big projects possible, like Chandrayaan 2, Chandrayaan 3, or Aditya Advanced Spacecraft, or the very recent one, Agni 5, the Intercontinental Ballistic Missile. And there are just three, Dr. Ritu Karidhar Srivastava from ISRO that worked on Chandrayaan 3, Srimati Nikar Shaji from ISRO that worked on Aditya Advanced Spacecraft, and Srimati Sheena Rani from DRDO that worked on the Agni 5 missile, and many, many more that I would not fit into one slide. Big shout out to all of the women in those sectors. For today, I will just briefly go about what object-oriented design is and how graphical means can be used effectively in software design and software architecture design. What UML modelers are, UML modeling is, and what NI group development suite is, and the LabVIEW based UML modeler and its applications. Now, in object-oriented design, the key concept comes down to classes and objects. Now, class is a group of private data types, group of primitive data types that are coupled together with some function to alter them. And the object is any instance of that class. So if you can see in this screenshot, we have two separate instances of add class and a method of the add class also. These instances can hold different data, and this same operation.vi, there is only one of it, and it can work differently on both of these instances, and it will produce different results based on what data was inputted. So whatever function we are defining in a class are called methods because they can alter the state of the class. This wire holds the private data of the class that can be seen here as a cluster of primitive data types. And they are also called attributes. Principles of the object-oriented design. So there are four basic principles. Abstraction, which deals with what data to share with the outside world and what to keep as private only. So a class doesn't need to display all the data, doesn't need to show all the data to the outside world, only the data that is required by outside world. So that abstraction concept deals with that. Encapsulation concept deals with how the class modifies the data and how the outside world can see it. So for that we have different scopes: private, public, and protected. So if you have your methods in a private scope, the outside world cannot see how it works. But if it's in a public scope, outside world can see and use that method. In protected scope, only parent can see and only child can use that method. In inheritance, inheritance the property of any class which it can use to override or extend the operations of another class. So whichever class extends the operation is called child class, and whose operation it extends is called parent class. And polymorphism refers to the ability to change forms at runtime. So like if in this example I have, first of all the classes in LabVIEW are inherited from LabVIEW object. Then I have defined one class, numeric operations, which inherits from LabVIEW object by default. Then I have defined another class, add, which inherits from numeric operations. And if you can see, when they have the blue icon, they are all belonging to numeric operations. but since I have an operations VI that I have inherited from numeric operation inside the add class, and when I wire the add class to this set of VIs, the operation VI changes its form and basically exhibiting the polymorphism. For this to work, you need all of the VIs having dynamic dispatch type terminals. In graphical, when you are dealing with some complex modular architectures, you need a means to visualize all the flow, how the flow works from module to module. Sometimes you might need to explain that to a non-technical person. In that case, some tools are very helpful, and like some data modeling tools. We have different data modeling tools, many kinds of. For example, entity relationship diagrams that deal with entity, which is an object, and some attributes, which are the private data types of it, and their relationship with the other modules, other objects. Other than that, we have class responsibility collaborators. These are uh, index cards which are divided into multiple sections. One section refers to the class itself, the whatever class you are using. Second section contains the methods that are defined, that define its responsibility of the class. And the third section will be collaborator, which are the other classes that are going to interact with this class. Third one, we have these UML diagrams. So UML stands for Unified Modeling Language, and it is a open standard for visual modeling language. It is helpful in design and analysis of software architectures. It contains a number of, it can exist in a number of diagrams. So, and it is obtained by, it is maintained by object management group. There are several types of structural and behavior. There are several different types of UML diagram, basically classified as structural as well as behavioral. So structural UML diagrams deal with only the structure, the components, and the relationship between components in a diagram. The behavioral diagram deals with how the object deals with itself and outside entities. So for structure, we have class diagrams, which contain class and its attributes and its methods. And we have object diagrams, which include also classes, their attributes and link between the classes. And we have package diagrams, which can represent packages as a file folder kind of structure and can include multiple classes, multiple packages inside it. In behavior, we have state diagrams, which can represent any system as a state and with a transition between different states. We have activity diagrams, which can show activity based on a set of activities based on the conditions being true or false. And we have different tools also to create the UML diagrams. For example, a very popular tool is Plant UML. Another tool is Lucid Charts, and another tool is Draw.io, which is a very simple tool. And this activity diagram, if you see, I have drawn it on Draw.io. This UML modeler for LabVIEW, it comes as a tool as a part of a nice group development suite. So group development suite provides some template classes for you to work on. You can create some template from the shortcut menu when you go to your My Computer. You can add some template classes. You can add design patterns, and these template classes can be of different kind. It can contain DVR based classes or queue based classes or simple native classes. And these actually promote object lifecycle management. It will provide you with methods to create your data, destroy your references. And other than that, the GDS provides numerous, very large number of customization options, like adding design patterns, editing class icons, class appearances, cloning a class, and even editing these three icons with a single click. To install this GDS, you can go to VIPM, the VI package manager, and install the GDS from there. It's available there. And in UML modeler, so LabVIEW has its own UML modeler that you can access from the shortcut menu of any class. Here, if you go to UML modeler, it will allow you to access that. And you can basically for the it is most likely used for most prominently used for the class diagrams only. So class diagrams, you have multiple options. You can create classes, you can create interfaces, packages, and you can define relationships between them. So if I have this class, two classes, there is an association relation. That means class 1 is using some method of class 2. So class 2 is associated to class 1. You can have aggregation relation. That means class 1. Yeah, you're right. OpenGDS, the NI-GDS is currently not very updated, but the OpenGDS has all the updates and support for the new LabVIEW interfaces as well. So in aggregation, if one class is composed of other class, so like I have this class instance added in the private data of this class, that counts as aggregation. But in operation wise, both of them, composite aggregation and aggregation are similar. Only difference is the life cycle. If the life cycle of the container class, the composed class is different from the container class, it doesn't depend on the container class, it is aggregation. If it depends on the container class, it will be composite aggregation, aka composition. That's a very good news if you are adding OpenGDS to VIPM. That will be very helpful. Other than that, we can define inheritance relation. To add this relation, you just need to click on any of these and drag this across one class to other. So here I have added this inheritance relation from class 2 to class 1. That means class 2 inherits class 1. And I have added an interface also. So interface will allow you to add methods only and not the attributes. And you can also add this interface implementation relation. Other than that, if you right click on your class diagram, you can also apply a lot of design patterns. As you can see, there are a large number of design patterns available. You can add any of them. And to create some template code, you can also take some template code for it. Now, for my first demo, I will show how to generate the code from a UML class, UML diagram. Here, if I have a empty project, I will go to Tools, UML, open UML model, and when it opens, I can add some. I can click on class and class control. I add some class. I can add its name. When I double click it, it will open the edit class properties. I can add some attributes. I can add some methods, and I can drag and copy it also. Then I will just change the name, and I will create another copy. I will change the name again. Now I will use the inheritance tool. I will drag this tool from add to numeric operations, subtract to numeric operations. Now, this is supposed to signify that add and subtract inherit from numeric operations. If I go to tools and select generate code from UML, it will give me a dialog that will ask me to use the class provider. So we have different kind of class provider. The most simple one is LabVIEW native. And I have the option to edit the class icons and colors as well. If I press OK, it will generate the code in the background. And as you can see in the project explorer, 3 classes have been created: add, num operation, and sub. And if I go to the properties of add, In inheritance section, you can say add has been inherited from num operations. If I go to properties of sub is also inherited from num operations. And you can see some cleanup and init operations, init methods that are the template methods that are used to initialize or destroy your code, all the references. Now, for my next demo, I will show how to generate UML diagrams, reverse engineer code and generate UML diagram. Now I have this project where I have 4 classes, all add, sub, mul and divide, all are inherited from num operations. If I go to operation vi of add, and I add an instance of subclass from to the add operation vi in the add, and then I go to the private data control of null, and I add the instance of the class to null. And so this is supposed to generate some relations between the classes. If I go to UML, view all classes in class diagram, I have this another dialog that is asking me to reverse engineer. So I can add some top VIs, classes, directories, and I can also choose to ignore all the libraries, add a main application node, create typeless or not, create inheritance classes or not. So if I click OK, it will start reverse engineering, and now it has created the UML diagram from the code. Here you can see between add and subtract there is an association relation because I added instead of sub in the add class, and there is a composite aggregation relation between mul and div because I added a instance of div in the private data of mul. Other than class diagrams, we also have state diagrams we can generate in UML modeler. So in state diagram, you can add an initial state that is a solid black circle and some final states that is a solid black circle inside another circle. So, and in between you can add some states and the transition between the states. This is a basic chess example here. You can add initial states, final states, and the transitions, and another state. And you can generate state diagrams from the code as well, from selected code. So in this demo, I have a state machine, a simple enum state machine, where I have few states. First is initialize, and by default it leads to state 1. And in state 1, based on the output of the switch, it will, if it is true, it will go to state 2 or exit. In state 2 as well, if the switch is true, it will go to state 1 or exit. And in exit case, I have just looped the exit state again, and I am stopping the loop. If I go to tools, UML, open UML view, we are in state diagram now. So it will progress in background, and it will open another dialog to reverse engineer. So here I can choose to add comments as actions in the state. So it can also read sub diagrams. I can ignore states that are not used, and I can also search for sub VIs for more actions. And I can specify whether I'm using a queued message handler or not. So when I pressed OK, it analyzed and it created a state diagram. Switch states for the name of my VI. It created some initialize state 1. State 1 can lead to state 2. State 2 can lead back to state 1. And state 1 and state 2 can lead to exit. So this way it created this state diagram. But bear in mind, you cannot reverse engineer a state diagram into a code because there is not enough information. You can only do this from code to generate a state diagram. Other than state diagram, we have sequence diagram and use case diagrams that we can also generate in the UML modeler. In sequence diagram, you have object, and based on the order in which they send message to other objects, it can be synchronous or asynchronous message, and or they are also called calls. So they can send a call, receive a reply, and it is all based on the order of operations, which is sent first, which is sent later. In use case diagram, you have an actor, which is essentially a user of any system, and it can lead to an action, which can lead to further actions. So how a user interacts with the system, the use case diagram is based on that. So here are some reference links. Uh, you can, if you want to use OpenGDS, you can go to opengds.github.io, because it is mostly updated and it will work with the latest version of interfaces also. Thanks a lot. Any questions? Also, if anyone is curious what are the features of GDS, there is a presentation from GLA 2021 by Mikhail Nordstrom, and which is very informative about this group development system. He is using OpenGDS, but it has explained a lot of features and it is very informative. You can go check that out. But thank you all for listening in for this. And it's an honor to present on GLA Summit, and I'm very very thankful to the organizers for this opportunity. Thanks a lot.